Now we're going to look at number 1 from the Chapter 5 AP packet. A particle moves along the y-axis with a velocity of v of t equals t sine of t squared for t is greater than or equal to 0. In which direction, up or down, is the velocity moving at t equals 1.5? A lot of people have a tendency to try to make sign charts to make intervals, but it's already telling you what time you're supposed to be looking at. If I'm trying to analyze which direction the particle is moving, if the direction is up, I know v of t is positive. If the direction is down, I know v of t is negative. So which one is it? Is it positive or negative at 1.5? All I have to do is plug in 1.5 into the function, and that'll be 1.5 sine of 1.5 squared. And I believe this is a calculator allowed. I just checked, it is. So therefore, let the calculator determine the answer, and I end up getting 1.167. What do I care? I care about that this is greater than 0. I need to show this comparison. So then I can say, since v of 1.5 is positive, the particle is moving up. This question is worth 2 points, 1 for coming up with this answer, and then 1 for the justification. Part B. Find the acceleration of the particle at t equals 1.5. Acceleration of the particle. Given that velocity was t sine of t squared, acceleration is the derivative of velocity. Be careful, I see t times sine of t squared. I see a reason to use the product rule and a reason to use the chain rule. The chain rule comes from the t squared. So let's start with the product rule. Start by taking the derivative of t, which is 1, and keep sine of t squared the same. Plus, now keep t the same, and take the derivative of sine of t squared. The derivative of sine, we know, is cosine. Keep the inside the same, and multiply that by the derivative of the inside. I don't need to clean this up. The next part says, is the velocity of the particle increasing or decreasing? That would mean, is the acceleration positive or not, or negative? So I'm going to plug in a of 1.5, which is the same thing as v prime of 1.5, into all of this. So that's sine of 1.5 squared, plus, if I wanted to clean this up, this is 2 times 1.5 cosine of 1.5 squared. I'm going to figure out this in the calculator. And I got negative 1 point, sorry, I forgot a squared right here. So again, I would have gotten negative 2.0487, which can be rounded. So now let's make sure we answer the question. Why or why not is the velocity of the particle increasing? No, because v prime of 1.5 is less than 0. That's all you have to say. But it is really important you do say no. You have to answer the question and then explain why. So this also would be worth 2 points. 1 for showing this. That also requires all the work prior to show what the derivative is. Now you could have used a calculator here. Because the calculator is allowed, you're actually allowed to make this jump from here to here. And then of course 1 for having the answer to the question. For part C, Given that y of t is the position of the particle, y of 0 equals 3, find y of 2. As soon as I think about this, this is a starting position, this is where I'm trying to end, and it says using the fundamental theorem of calculus, I can do displacement equals end minus start, but this is not the one I'm used to. The one I'm really used to is end equals start plus displacement, which means y of 2 equals y of 0 plus the integral from 0 to 2. Now, this always has to match up. If these don't match up, then it won't be right. If I'm trying to figure out what goes here, it's the derivative of y. So in this case, y prime of t dt. I know y of 0 equals 3, so I can say this is 3 plus. Now the integral of y prime, well, if y is the position, then y prime is the velocity. So what I want is the integral from 0 to 2 of v of t dt. I punch that in the calculator, and I get 3.8268. No units attached, no justification needed. This is my answer. This one is also worth 2 points. 1 for setting it up, 1 for the answer. Last, find the total distance traveled. Total distance traveled of the particle from 0 to 2. That would be the integral from 0 to 2 of the absolute value of the velocity. Nothing else besides the velocity. On a calculator allowed question, it does not matter how you get to your answer, as long as you show your work of what you would be able to compute. Your answer is 1.173. This question actually has 3 points connected to it. 1 for the integral from 0 to 2. You need those limits. 1 for the absolute value bars, and then 1 for the answer.